Okay. So, yeah, madam. Ngram is a sort of a bag of words related technique where when you are looking at every word as a token, right, you can choose a token for one word. So we discussed just a prelude, we discussed three formats. We said initially it is all symbols oriented and lexical format of data analysis. So we checked the word net. So word net had synonyms and hypernyms. Second, we looked at static vectors. So in the static vectors, what happened? Every word had one vector. So n-gram refers to you can have two words, two adjacent words as a vector. You can have three adjacent words as a vector, and you slide by one step, which means let's say I am from Andhra University. I am from Andhra University. So five words are here. Now, in an n-gram, you choose a 3-gram model, let's say. So then your first vector your second vector represents am from Andhra. Your third vector represents from Andhra University. So this is n-gram. Now, next you asked global vector. Global vector is one of the initial methods in 2013. Yeah, maybe I'll cover this as we progress, ma'am.
Thank you, sir.
పని ఎప్పుడు ఉంటుందండి పని లేకంటే మనిషి అవడం పని లేక ఇక్కడ ఉంటున్నాను ఇంటికి వెళ్తే క్లాస్ వినలేము ఇక్కడ క్లాస్
You need to pause, you need to mute.
Sir, Molly, sir, please unmute yourself now. Sir, can you please unmute?
Yes, madam, unmuted. I don't know
Okay,
how.
sir. Okay, sir. I just muted all the. There was a disturbance in some people.
Oh, okay.
Okay.
No problem.
Okay, sir. Okay, sir. Thank you.
We'll just wait for others. Let me know when we can start. Good evening, everyone. Yeah. So Nagajyoti madam is asking for unmuting her. So ma'am, what we can do, let us unmute everyone and whoever is talking, I think we expect them to mute themselves.
It happens, sir. We'll check, sir. But if they doesn't hear to us, it will be a problem for you. Okay, I'll mute all.
We can block
all.
them that time. We will that time take control.
Okay, no problem. Now they can unmute themselves.
Oh, nice. You'll tell me when to start. Okay, so Venkatesh Garu, have you joined? Okay. Madam, you will let me know when we can start.
We'll wait for another 5 minutes, sir. I'm
Okay.
just posting the message again so that they
Okay.
can join.
Done. Done. All. And,
Sir, you can start the session, sir.
yeah, I'm
Yeah,
thinking.
thank you, sir.
All. So let's take a quick look at what we have discussed in the last 2 days and what we wish to do today. Anybody wants to share what we discussed? Okay. All right. I'll probably do. So day one, we spoke about history, evolution, and so on, and how this NLP over time progressed and what are the advantages that we have got in order for NLP to flourish. And today, why NLP is sort of booming within the whole AI space. Day two, we spoke about transformer architecture amongst many other things. We also highlighted at a next level what are the symbolic representations initially we had using WordNet and so on. And then we moved to vector representation. They are all scalar sort of, they are more scalar sort of static vector representations initially. Then we also moved to the more distributed numerical representations through the more new age methods since the transformer architecture, where they were keeping the context in mind. All right. Then we also looked at some bits of code. Today, the emphasis is around three aspects. One, we will dive into the GPT, and we will also look at briefly the BERT architecture, and we will have some sort of a prelude to how all these language models are progressing. So I want to quickly check, is there anyone who has not used chat GPT until now? Anyone not used Chat GPT? All right. So I have a query saying, I'll take these queries. So one yesterday's session, if I could recap, we spoke about these three aspects, right? How symbolic methods, so lexical methods were there using WordNet, and we also ran the code. Then we moved to Word2Vec and Glow. So, and how their methods, how did we find the objective function? There is the center word always, and it is looking at outside words, and it doesn't matter whether they are left or right, strictly speaking, because they are a bag of words providing some bit of context, but there is one static vector for every word we got. So we discussed that. And three, a big thing that happened is transformer architecture. I think if I have to really go into details of transform. Do you want a recap of transformer architecture? Okay. Anyone else looking for a recap on transformer? Okay, sure. So just about attention module within the transformer, I'll spend more time on the attention. So what you can see, yeah? Or I'll just use the same thing only. Just give me a minute. Okay, good. All right. So we'll emphasize more on the attention here. But then if you look at on the screen, right now there is this sentence we chose, the rock rules, and we want to provide contextual representation for every word along with the adjacent words. Now, the next step that you see here is an X47 is a token number. And we also said earlier, we provide positional embedding. Positional embedding. So each word has a positional embedding. They're summed up C input. So we will focus the C part, and the same parallel one runs for the rest. Now C input is the input word, the input vector which is available, and it goes through an attention mechanism. So attention is nothing but a dot product of this particular vector C input with the other vectors that are there. So in the dot product, what we do, you see the dot and connection, C input dot product with B input and C input dot product with A input. Now, this dot product, what the authors have done is to scale the data better, or they found they were able to scale the data better when they divided by number of dimensions of the vector. And I shared BERT used 768 dimensional vector. The Word2Vec typically had 100, 200, and 400 dimensions. So the divide by square root of those dimensions gave more scaled data. That's how they did. So, but essentially it is a dot product of each word vector with other vectors. And softmax is applied to the output. In the softmax, what we do, there are two things. One, the value is exponentiated and divided by sum of all the values that are present. So once the softmax is done, the C attention is computed by summing up for every word. So this is alpha 1 with A input, alpha 2 with B input. For each one, again, it is multiplied with those vectors, and C attention comes. Now, this you would have seen represented as query, key, and value. So query here in case of C input as a word vector is, this is query, and it is the dot product of queries with the keys. So you could either say matrix of all the words, or in this case, I showed one after the other because this is how Professor Potts represented. So that dot product is with all the keys. And if you see in the sum, you again have A input, A1 input, and B input. this A input and B input are nothing but the values. So another representation you normally see is it is the sum of softmax, no, sorry, it is the softmax of exponential query into key divided by square root of dimensions into the values. That's how you would say, but both represent similar. I think one another aspect here is you see multi-attention heads. It's not a single attention. So what would happen is there will be, say, three attention heads, and each attention head does the same thing again and again. So every time you have a new attention head you are doing, you will generate more parameters. All right. So post the attention head you get, the next step is the data gets normalized. So you sort of normalize it with mean being 0, so that all the values, oh yeah, even before the normalization, we have this CA layer. Basically, this is a regularization layer. I also couldn't immediately come. So the regularization layer, essentially, while it carries the data of C attention, it drops some values of the attention layer and carries the input layer fully. The idea for the input layer fully is so that it doesn't lose the original content that was there. So that vector comes here. Now this lengthy vector, at every stage, it is a 768 dimensional progression that happens. Vector size doesn't change. This data, this regularized data now gets normalized, where mean is kept 0. So all the values are scaled to smaller size. So once it is normalized, so the attention block uses two feed forward layers. So you flatten it and keep feed forward layer. Each one there, the number of dimensions are more. So here you see CA norm is a layer minus mean of that layer divided by standard deviation. Now, so the, sorry, feed forward layer, two feed forward layers we use, and the ReLU activation unit was recommended there. Now, on the top of feed forward, again, you have lot of data. So you normalize this data again. So normalization you do once again, and whatever is the normalized data, you take that out as an output. Now the output is again back to 6768 dimensions. During normalization, oh, I missed again. So before normalization, we have the ReLU data is again, some portion of it is dropped, but the CA norm is completely carried. So once you regularize it, on the top of it, you normalize it, and this is one single block. Now, all right. So while this is one block, I will now go to the diagram where it is available quickly. So that, yeah, this is the diagram. So what we just discussed is this one block. Now you can see input embeddings has positional embeddings. It has three arrows going up as multi-attention head. But then once the attention data is computed using softmax, and the previous original value goes back, gets added and normalized there, scaled, data is scaled. So the regularization part is within this multi-headed attention only. Multi-headed attention itself has two pieces, attention and then regularization with some dropouts. On the top, feed forward, again, it also has add and norm. So encoder block, if you look at BERT, is a common one where there are 12 such encoders are available. In a BERT launch, 24 encoders. On the decoder side, there is a small shift that happens. Decoder side, we have again, output embedding. Initially, it is start of the sentence, or depending on each one, or separator, depending on each model that we are using, that passes through. Initially, the values may be null values that goes. But then if you notice, the key is coming from here. Query and key are coming from here. Value is held back here. So query and key comes. So then again, the multi-headed attention, adding normalization, those steps are similar. These blocks are another 12 blocks. Connection is normally kept in the first decoder block, the encoder to first decoder block, but there is no hard and fast rule on where you want to keep the connections. Finally, whatever is the output, number of probabilities, let's say your word vocabulary has 29,000, 28,000 size. So those many probability options will be there. You use the softmax. All right. Any query on this? Okay. you can post there is something that you want to ask. So today we will emphasize a lot around GPT method. I'll run the method and so on. Yeah, and normally the transformer architecture, I think I read so many times, participated one shot, two shot, comprehension may be difficult, but I think high level intuition, if you can pick up slowly, I think you will be able to get familiarized with it. Now, all these models, right, when we train, these are all self-supervised models. The third level where we said we are getting a distributed representation of words. So where co-occurrence pattern, one with one word, what is the likely next word that can occur? So that's where your probability, right? It is next word probability. So self-supervised training is being done. The objective is primarily co-occurrence pattern. You can also assign high probability to attested sequences. Once you have that sentence length, you could preset high probability to occur for them. Some advantages, many disadvantages. Generation then involves sampling from the model. So now these sequences can contain anything, and so far largely the corpus is taken from online to train the models. Earlier, it was spoken in terms of the size of the data in GBs. Now, the discussion is about number of tokens that are there. So 2 trillion tokens and so on. I'm sure you understand between word and token, there is a distinction. So roughly you can say 0.6 to 0.7 words would be one token, because in this, let's say, you will have comma is removed and object co-occurrence, co becomes one occurrence, or occur and rents become different tokens and so on. So sequence, it is broken into multiple tokens, and expected is the next token it is able to predict. So the in terms of growth, the first article that came, which is sort of a transformative, was distributed representations of words and phrases and their compositionality. So in this case, where they were able to look at the position of a word by looking at the rest of the words that are there. However, the rest of the words do not really have an identified position that could be anywhere. From there, we had global vectors for word representation. So this brought so much of good work from the perspective of there was a clear similarities that were identified. Man and king were together in a multidimensional space. Queen and woman were together. Locations were together. I showed yesterday also some sort of word cloud where clusters were formed. That's from Glow. These clusters were more specific, and the distances between the related words were also matching across. From there, we moved to deep contextualized word representations. I think one of the initial works, 2018, this paper was presented by Allen Institute for AI. This is where they said you understand the context. Looking at the context, a word's meaning is identified. If you put it at a very high dimensional space, you will be able to capture all of the majority of that context. So this paper then opened up so many possibilities that we are seeing today. BERT, famous BERT, though it was the BERT model was released in 2018. In a year's time from Transformer, the actual paper was announced in 2019. So BERT was a bidirectional model where it is a masked language model. The intuition behind BERT is some 15% of the words of a sequence of a paragraph are masked, and the model, the training period, and it was iteratively attempting to figure out what are those masked words. We will look at the details. And the second thing that they did was with this masked words, the actual words were removed, and then some wrong words were dropped. Let's say pre-training of deep bidirectional transformers for language understanding. So instead of this, pre-training of hello bidirectional transformers for language understanding. So then they market this hello is a wrong word and make the model, train the model in such a way that it will identify a correct word. Now from there, improving language understanding by generative pre-training. So here we did discuss this language understanding, the language processing. The encoder-based models are very good with. They emphasize a lot on language processing. The decoder blocks emphasize on generating an output. In today's world, it is all about generation. So much focus on generating the text. So it's all oriented. So generative pre-training model came. The first one, this paper was released, I think, even before BERT, a couple of months before, 2-3 months before BERT in 2018, GPT-1. Today, we talk about language models are few short learners. So you have, you just give 2-3 examples, then it should be able to answer your next question in that pattern only. So with just those 2-3 examples, you will be able to get the model powerful. Now I'm moving to the sizes of it. Now, when you say language model, I'll ask this question: what is the output of any model, any machine learning model or deep learning model? What is the output? You can say or write. Okay. The class labels we provide initially. So input and that output is you provide for the model to know. That is why class labels are why. Now, when you train something, you create a model and you have to go and use it somewhere else. What is that you take from the model? Rules. Okay, architecture. The architecture is one you carry with you. No, yeah, good point. You're using the term rules. What are the rules there? They are called parameters. You normally call these as weights or parameters. So automatically, along with the parameters or weights, you are also getting the approach that you adopted, approach to for training. So you use the similar thing for inference purpose. So approach for inference will remain standard, but then the weights or parameters are your output. Now, over a period of time, the number of parameters of a model, right, they kept on increasing. I don't know, in machine learning, so if it is a y is equal to mx plus b, and let's say we are computing the weight of a person given some 10 different variables like height, age, diet, region, race, gender, and so on, then you have how many m's you get? 10 different m's. 10 plus 1, 11. So you have 11 parameters in a simple ML model, and it can go to 1,000, 2,000, 5,000 parameters also. 5,000 parameters based on the number of input variables. If it is your image recognition related, then the number of pixels that you choose, let's say 300 by 300, so 90,000 weights you will have, and you also convolute them, so you have these sieves, right? We call it as filters. Each filter has multiple frames there, so all of it is other weight matrices. They are weight matrices as you downsample, and so on. So all put together 90,000 and another 10,000 you take from there, 100,000, and you add another 50,000 when you fully flatten it. So typically you get 150,000 to 200,000 parameters. Those are the number of weights or parameters you get as a model output along with the architecture, the inferencing process. In case of these large language models, right? GPT of OpenAI, it had 100 million parameters. And I think, yeah, then BERT around the same time in 2-3 months, BERT came, and BERT had BERT base large had 175 parameters. I think I vaguely remember we should have the BERT base was 110 parameters, and BERT large was 175 million parameters. So imagine we were talking about 200,000, which are 2 lakh parameters, and suddenly here we're talking about 10 crores and 17 crore parameters. And this was a story of bird. Then came GPT-2 with much higher parameters, and suddenly there is a big jump with Megatron of NVIDIA, where they had announced 8.3 billion parameters around 2020. Now, that was a super big jump, 2020, where the model weights are so. And today, GPT-3 was announced in 2020 with their biggest model was 175 billion parameters. 175 billion parameters. So whatever you are working on, I think you are now looking at GPT 3.5 turbo, right? It is 175 billion parameters. It is passing through for a question to answer whenever you ask a question. We also have a great processing capability that is an advantage today. Now, Megatron Turing energy, they say it has 1 billion parameter, 1 billion parameters it has, 1 trillion parameters, Megatron Turing energy. So Microsoft partnered NVIDIA for this, and Google has released Palm last year. So that also has over a trillion parameters. Isn't it crazy, the number of parameters that are going? Yeah. So now the LLMs, if you look at, right, there are OpenAI has GPT, Google has Bard. It is powered by different LLMs. Let's take a Palm here, and Microsoft also has come up with different language models. Yeah, so it's really going crazily. NVIDIA, then Megatron with Microsoft. Meta has come up with Llama, and then now Llama 2. How many parameters are there in Llama 2?
7B, 13.
Oh yeah, Llama 2 has the higher one has 70 billion parameters. Meta's, Facebook's model. Then we have Falcon by a training institute in Dubai. So they also have, I think, 150 billion parameters and so on. So it's growing really crazily. Now, on the other side, you have some startups who came together, and notable names. Anthropic is not here. So Cohere is an organization which does. Oh, Anthropic is here. Anthropic comes up and says, look, are you building ethically or not? There was this question in the beginning saying, what is the difference between fair, where is it? I had a question, bias and fair bias. Yeah, that should be the question. Yeah, fair bias and bias. So bias is the intercept value. So where we are saying in a perfect world, when you compare y with x, you don't have that perfect thing. So there is some bit of bias. To adjust that bias, that intercept, you will add some value so that you could converge faster. This is bias. Fair bias is about oh yeah, I don't know what bias you're referring to. Now, fairness bias is typically about the model. If the model is fair or not, or is it biased? There was this 3 years ago when GPT-1 was launched. Somebody asked a question that it was that this somebody asked this question. Now, a particular religion person is in a coffee shop, and for that in this case particular religion person is in a coffee shop. So the model said that he is going to blast the coffee shop, better everybody run away from there. So it was so biased to certain religion, certain race, and that was an issue. Later it's been improved. I don't know if any of you used in November, December, January GPT, chat GPT. It was not fair. It was providing anything and everything of the data. So fair bias there is about how whether there are filters or not, whether everybody is looked at objectively or not. That's fair bias. In any case, there are startups who are coming up with quite powerful large language models. Now, there is one very interesting trend that is slowly picking up, which is not going after these large size, large parameters models to smaller models with reasonable accuracy or matching accuracy or sometimes even superior accuracy. Uh, One example here you see is Llama 13 billion, and I have used quantized version of 13 billion, quantized version of 7 billion I used, and it is very good. Llama 2, 7 billion quantized version. It can match to a great extent with, it beats GPT-2, definitely. So slowly, so you see Alpaca by Stanford, they have come up with another 7 billion model, which is reasonably good and was able to do for certain domains. Now, Dolly is by that Databricks. I think it is Databricks. They also came up with a model, fine-tuned model with low billion, fewer parameters compared to all these gigantic, I don't know how to even say, super large models. All right. So now GPT-3 is a first step on the path to foundation models. So there was this artificial general intelligence. It can answer any question. So I think this is the starting point, and I will just run a couple of questions on GPT-3 to say, we'll ask, can you, this is a complex one, write a, give me lyrics in the way that Siri Vanilla Sita Rama Shastri writes. Now, this is like a very different question that I asked, and we'll see if it offers. Anyone listens to Sita Rama Shastri songs? You can speak out. I think you can unmute yourself if you want. You can say. Huh. Yes, ma'am. I listened to him and I felt very, very, very sad when he passed away. Very, very sad. And that day, interestingly, yeah, thank you. That day, interestingly, I was listening to the first Siri Vanilla song and so on. Now, let's see yeah, truly. So, what did it write and see if it makes any sense? So, lyrics in the way that's was renowned, yes. You can attempt to create lyrics in a similar, here's an example. Okay. Are you able to read this? Okay. Yeah, it reminds me of one old song where Mammootty acted in the Swati Kiranam, I think. In that movie, songs are somewhat similar. Agasham Nakshatram Samoham. Okay. Not bad. It did well. Yeah, it did well. Yeah, it did well. So look at how it is able to do. So now we will ask a question, something where we'll give some prompt. We'll say you are a computer science faculty. You are a data science faculty. You are an expert in NLP. For every question the student asks, you provide its meaning, mathematical foundation, any applicable architecture details, and its applications. Okay, we'll just give this as this is like a prompt. Now, question is, what is transformer architecture? Let's see if it can pick up. Okay, it is now it's a second output is coming, so it's still. So all that we asked is what is transformer architecture, and this we gave as a prompt, and let's see what it is. Then blah blah blah. Attention is all you need. The core idea behind it. Scaled data dot product attention. It is scaled dot product because it is divided by a square root of dimensions, right? Allows to be important in different parts of blah blah blah. Self attention can be presented mathematically using query key value. No architecture details. So it has two components: encoder, decoder, blah blah blah, multi-heads applications. Now, can we beat this? So we just gave a prompt, and then next we'll ask another question like, what are positional embeddings? Nothing else. We'll just say this and see what it will answer. See, it has a memory of the previous one. How can we attend info provided by ChatGPT? So I'll give you more details tomorrow too, but today I'll give the intuition how to get the authenticity of it. Positional embeddings, it says meaning is something mathematical foundation. So okay, see what did it write? So in a word's order in a sentence or sequence is essential. Embeddings help model account for that sequential nature of language. Perfect. Now, mathematical foundation, these are high dimensional vectors. These command on sine or cosine functions, often based, but I think now we have many more methods. Each position is associated with a unique set of sinusoidal functions of frequencies. Good. One it gave. And the position embeddings, how they are calculated, it has provided some details here. So POS and so on, architecture details, applications, blah, blah, blah. All right. Now, so the question that we've got is, how can we authenticate whether ChatGPT gave a right answer or not? Now, you can use a method called retrieval augmented generation, where you tell the GPT to answer a question only from your data. Do not answer a question from its general knowledge, but answer only from your data. Let's give a question here and we'll pass a context. Okay. Let's take any news. India versus Japan live session. Okay. Okay. We don't get a decent news, man. Okay. Oh, this is fancy. So, how? Very bad. I can't find some decent news. Okay. Basically, I'm looking for, I'll just take any paragraph. Oh. So, we will take this paragraph. Now we will ask ChatGPT, answer question only from the given context. Do not use your general knowledge. If you do not, if the context doesn't have an answer, simply say you do not know. Let's see if it can handle the context. But I'll show you how we can do it. I run the code also. I'll run some bits of code today. Retrieval authenticate model. So this name that it's called retrieval augmentation. I'm going to spend retrieval augmented generation, RAG is a technique we can use to get data only from your information, from your knowledge base. Okay, but we'll talk about it. That's a very critical aspect. Content, the ministry said that the earlier regime was impacting between Indian and the ministry. It is estimated. So we'll say question: who is Prime Minister of India? So do you see this? It says the context you provided does not contain information about current Prime Minister of India. Therefore, based on the provider, I do not have information about the current Prime Minister of India. Let's say now, since this is there, and hoping it is there in the backdrop, it says by legal and dealing with aircraft finance, that Indian carriers spend 1 point more than earlier in lease because of the impediments. So, okay. What is the impact on Indian carriers due to impediments in aircraft recovery? Okay, let's see. I'm assuming that it keeps anyways the provided context mentions that the earlier insolvency and bankruptcy regime was impacting agreement, blah blah blah, according to this estimated early cost. It said, okay, now I said who is let's say the who is give me a famous name, person's name. Barack Obama. It is missing. So I think it's now gone a step. But if we ask a question with this context, it will not be able to provide. It should not answer. Generally, it should keep who is. Unless they have kept some filters to override. Good. So it doesn't, therefore, based on the given context, it doesn't figure out. So this is the level of capabilities that GPT has introduced. I have some questions, but let's proceed to. So this, therefore, is a starting point for a future we are going to experience, I would say. Now, there are more details about how much it has done, but what is happening here, if you notice, even in GPT-3, we just tested in GPT 3.5. So in context learning is extraordinary. So whatever data you provide, today I will show you a GPT-2 response and a GPT 3.5 response. I am hoping if I give you an exercise and I will, would you have GPT OpenAI APIs, OpenAI API keys? Do you have a key with you where if I ask you to run a small piece of code, will you be able to run with your code? How many of you have? Okay. I will give my personal API key till tomorrow evening you can use. Okay, I'll share my API key. You can use till tomorrow evening. All right. That's my personal one. So it's not a problem. Okay. So in context, it is able to pick up exceedingly well. Now there is a pure self-supervision vis-a-vis regular supervision. So regular supervision allows for few short in context learning, but so we will go into details as we speak. And chain of thought reasoning is also very good. See, what did I give? I gave the prompt, right? I gave context. So the context and the prompt saying you play this role. So prompt engineering, you would have heard prompt engineering become a big profession, or at least sought after profession. I think it's not just about writing the prompt, there are other pieces, but then that's the prompt we are talking about. So there is a big shift in this prompting. So we can provide a sample and say, this is how you have to behave. This is one old example. It says, the question is it true that if the customer, oh, this is answered by even text Davinci, interesting. Is it true that if the customer doesn't have any loans, then customer doesn't have any auto loans? That was the question. So if the customer doesn't have any loan, obviously even auto loan is also not there. However, the model said, answer it gave is, no, this is not necessarily true. A customer can have auto loans without having any other loans. It just reversed the question, not giving an answer over here. This is of past 2021. Come to 23. Now your prompting can be really, maybe tomorrow we'll share our solution prompt, how detailed we can go. One or two examples I'll provide. Not necessarily, even online you can see. We can give explain your reasoning in detail, then answer with yes or no. Your answer should follow these 4-line format. Premise. So you just saw, I gave how the answer should have. There should be mathematical foundation, there should be architecture, there should be applications. All of those details you can provide in the prompt and it is answering. And there are more examples, one more example that we have. Now, before I go to a next step of what other things happened to these language models to become super powerful. So these are more in context, latest language models. I'll give a pause for any questions of yours. Okay. So with API key, you can call the model. So the GPT is a service being provided by OpenAI. So generally, what do you do? If you want to run, make use of any model, you download it. Let's say scikit-learn, sklearn, you are downloading the library and making use of its functionalities, right? Now, in case of this language model of OpenAI, it's providing us access to their APIs so that whatever function, the format in which we have to call them, if we call, you can get responses. So the advantage with this is you can use your own data and get it trained, or you can build your own interface and offer it to customers or users or for testing purpose with that API key. So here, otherwise, you only go to Chat GPT. Okay. Any other view? Miss Venkat garu రాలేదు ఇవాళ. Okay. Any other question? All right. So now things progressed some more, especially November 2022, November 30th or November 15th. They announced GPT-3 improved version. In this, they said we are using reinforcement learning and with human feedback. So you would have seen something like this where they said the step one is you collect the data and basically you collect the data from experts. A prompt is sampled from our prompt data set. A labeler demonstrate the desired output. So labeler here is an expert in that area, somebody who is proficient, has given an answer. This data is used to fine tune the model with supervised learning. And you said that for this question, this is the answer. So you say maybe as the next sentence as pairs, question and answer pairs are provided to the model for fine tuning, and it was fine tuned. The base model is fine tuned on the top. Next, collect comparison data and train a reward model. This is another interesting piece. A prompt and several model outputs are sampled. So now there will be a set of questions, and for those questions, answers would come, and an expert, a proficient person will rank the answers. So for a given question, there will be 3 or 4 answers that would come. Within these 4 or 5 answers, within these 5 answers, let's say here in this example, you see four answers. The proficient person, a human, will say this particular answer 2 is the best answer. Answer 3 is the second best answer. Answer 1 is the third best answer. This way they rank that. So this data is then used whenever the correct answer has come, those probability, those values have come out, that path will get additional weightage, so that gets more importance. Yesterday I briefly spoke about greedy. Oh, I didn't say. Did I tell you the difference between greedy search? Yeah, even if it is repetition, in greedy search. Okay. So in greedy search, what happens is the best output, only one best output it takes. Let's say we have a sequence of 5 steps. In the first step, we are looking at what could be the next word. Let's say the A. After that, new, old, bad, good. Let's say it picked new. After that, what is the next best word? A new phone. Instead of prompt, it picked the phone. After that, it goes only in the thread of that phone only. So in greedy search, whichever is the highest probability value it contains, it will only show that path. Now, on the other hand, a beam search, which is currently in vogue, at every stage after A, it looks at what are different words which have high probability of occurring. So it will take some 4 or 5. You can choose that. In case of GPT, at least you can say top P value. So all those 4 words it picks, and it could be new, old, bad, good, 4. And it will predict what are the next in the sequence, what would come. And when the sequence moves further, whichever sequence has reasonably well set probabilities, that path is chosen finally. So beam search, though it is the infra intensive, it is likely to provide higher accuracy. So in the step 2, we are looking at whatever the proficient person marks as good, they rank them as which is a better response and which are okay responses. Basis that the whole model is rewarded on the better responses. Third step is optimizing a policy against the reward model using PPO reinforcement learning algorithm. What is PPO algorithm? So it is a policy proximity optimization. So those of you who do the policy proximity optimization, where we are essentially saying whenever you find the right answer, the reward is given, you add more weightage to that, and wherever it is less, you give a negative weightage over there at a high level. So you're reinforcing the right method, so and penalizing the rest of them. So in this case, thank you. Proximal policy. So proximal policy optimization, but my intent is similar. I couldn't recall. New prompt is sampled from a data set, and the PPO model is initialized from the supervised policy. And it generates an output, and based on the output, it calculates a reward, whether it should be more weightage to be given or less weightage given, and that reward will goes through. I found Llama 2 was fine-tuned on chat. Tomorrow I will show their method of optimization. I think they also used proximal policy optimization, but then the whole RLHF method was beautiful, where they analyzed the step of reward against 2 parameters. One was the performance, accuracy. Second was the safety of it. And also they published the large size of labeling that they have done in the second step. Summarizing the RLHF, in the first step, the proficient people are asked a set of questions and they were expected to provide answer. All those questions with the answers, those pairs are given to the model, and the model is now trained with question answer pairs. Second step was the model is asked, given a set of questions, and it was expected to answer. and it will give 4 or 5 choices. It will give four answers for everything. Between these 4, whichever is correct, this expert person will label them as this is the correct one. These are not necessarily right. So rank order them 1, 2, 3, 4. Give it back to the model. So once you give it back, then you reinforce it by saying, okay, wherever you have a right one, give the additional weightage to that. So you get the probability of occurrence of those words will be higher compared to the other words across the whole architecture. Now this is one, and I will go to the next one is, I said retrieval augmented in-context learning. And when we, at least when I used, I did not even knew that it is called RAG method. However, I felt this may be a best way to do it. But it has, so the essence of this method is, while the model has so much of global knowledge, you will always expect an answer for your question from the data you provide. So on the left side, you see, now increasingly these are becoming AGIs, artificially general intelligence model, or maybe it is not even correct to say from a user perspective it is an AGI, but in the back, so GPT-4 has different models for different domains. At one level, domains are clusters. When you ask a question, it is going to all those models, and some sort of voting happens, and whichever has sort of high confidence level, the answer is retrieved from that domain. In any case, that is more an AGI. Now, in case of retrieval augmentation that you see on the right-hand side, the model is all trained. So whenever you see all these crisscrossed lines in the black here, that indicates a very dense network, very dense neural network, where it pass through, context is understood, and so on. From there, you provide your own data to it, and for a given question, for a given question, from your data, you pick up what is right, and you provide that as a response, move forward or backward. So in any case, the advantages for this is multifold. One, the fluency of it, or ability to accurately summarize. Two, efficiency of it. It is also much quicker. You will get the data. And three, updatability, which means if you see the answer is incorrect, right, you can go update your corpus, or in our case, we have established some validators saying that if you have seen in my data, only then you go and validate whether you really saw whatever output you generated was in our corpus or not, and then only you respond. Then provenance or factualness, the likelihood of we going wrong with our data on facts is very limited. I have one example I'll share. Again, safety, here you are not, if you go and fine tune a model, it is very expensive. And from a user standpoint, safety, you give the data and you expect only from your data the answer has to come. This is an advantage. I have few slides adopted from an, I think, Michael Potts, professor of Stanford. I'll share that.
Can you go back once? Is it just one more slide back? Okay.
So though my explanation was different here, it was a sort of elections.
So the external data to train, where is it coming from in terms of retrieval augmentation?
This one is did not provide in this example. It is only giving scoring, and from there it is passing through the next step.
Okay.
In reality, the model that it is passing through, right, that architecture that you see, the fully crisscrossed lines, it is carrying the question along with the context of our data. So I shared one example earlier. So let's look at this. Answer question from given context. Do not use general knowledge. Context is ministry said blah blah blah. And our question is, who is Barack Obama? It is, I don't know. Because that dark lines that you see, it has carried even this context.
Okay.
So when I say retrieval augmented, I am carrying my data. See, it will not, now this is a safer thing. You will not go wrong with it. In the explanation, I provided greater details of how exactly.
Okay.
Okay. All right. Now, if we look at efficiency aspect, now LLMs, you kept on going and working with super large, super gigantic models of 1 trillion, while there is this new trend that has come up where with 7 billion and 13 billion and flan T5. I haven't used, but I heard from an electronics, software electronics company that flan T5 is pretty decent for them to utilize at $3 billion. So smaller language models are cheaper to develop, cheaper to maintain, cheaper to deploy. You can do the retrieval augmentation. So it only has the base understanding of synonyms or context, blah 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 of every word, but then only your data is coming out from it. So Llama 2, that is why I'm very hopeful we'll be able to crack with high efficiency. Updatability, yeah, it is our data, so we will be able to update that data. We can make the change to the data and pass it. So what you see here, the numbers are from the vector database. Now, who is the president of US? It can stick to Donald Trump because that's the data that it had. It is not, and if you want to retrain with additional information, it is going to be really crazy. You have to run through a whole model, and it costs significantly higher. So factual data is always recommended go with either retrieval augmentation or additional filters you keep for factual data.
So is there any use, it looks like retrieval augmentation, in the previous one you mentioned all the benefits. Is there any case where LLMs for everything might make more sense rather than retrieval augmentation? Because I believe retrieval augmentation also starts a base model, which is LLM for everything, and then you are kind of optimizing it for your data, like your specific knowledge is given, right? So looks like this might be better off in most cases. But is there any case where LLMs are better than retrieval augmentation?
Yeah. So LLM, the direction in which LLMs are progressing are towards one model for everything. You call it as artificial general intelligence. So the first foundation model is GPT-3, which can answer any question and every question. So a child can ask what is 2 plus 2, and an expert scientist can ask how can I do stratified sampling of 3 million data where I have 60 variables or 1500 variables. What do you suggest as a construct for me? It provides the answer. So this kind of variety it is able to give LLM. Now it is like that wild horse, and now you want to bring that horse for a particular race. And it has to also get acquainted to a jockey. That taming is your retrieval augmentation. That's such a large one you are able to do. Now the bigger question is, when your data is likely to come from retrieval augmentation, why do you need a 175 billion or a 1 trillion? Now the Megatron, NVIDIA, Microsoft partnered with NVIDIA, and they're coming up with Megatron Turing, NLG. That is 1 trillion parameters one. You don't need that. For a real-time application, you need a small model which has a good distributed representation of a deep context understanding. If that is adequate. I'm just hoping you're all with me on the call. So a colleague of mine, he asked, yeah, RAG is a retrieval augmented generation. Perfect. Okay. Updatability, you can make updates and so on. Now factualness, this was though a few months old. LLMs for everything. So the question on the left side, you see, please answer the following question and provide references for your answer. So it says, are professional baseball players allowed to glue small wings to their cap? So the answer is good, but the references have no meaning at all. So if we attempt to make one LLM for all, we will not be able to get the right answer. Retrieval augmentation, on the other hand, is able to pick the link that you mentioned. In our company, we can't pick the link right now because links are not allowed through Teams, that adaptive cards or whatever. Through Teams, we are not able to fetch the links right now. All right. Safety and security. So user privacy is a challenge. Whatever we ask, we will have to rely on whoever has provided. LLMs are known to memorize long strings. And client security challenge. no known way to compartmentalize LLM capabilities. Now you are having that trust. So when GPT says, I will not use your data for training, after 1 month you delete, that's it. However, your data is still exposed to somebody. Organization security challenge are there, which with retrieval augmentation, you don't have that much problem. You still have some issue because you are sending those chunks to the outside world. That issue is still there. So you can bring access restrictions here because, for example, in our company, what we have done is there is a user assignment group who all can access a particular document. And the documents, only those people can access those documents. If you ask a question also, so that restriction we are able to establish through retrieval augmentation. If you have fine-tuned on our data and kept it open, then there is no way to restrict. Fine-tune a model with all of the data, which is another reason I am increasingly viewing fine-tuning may not support individual organizations. It can only support communities, large communities. All right, LLMs for everything. And so on and so forth. I think retrieval augmented is something which has answer to many of these questions. And wrangling pre-trained components is the future, is at least the present that I can say, though he can write recent past. The current is the already pre-trained models we use on the top of it. I will show another picture where
wrangling, sorry.
Triangle. So one over there. The typical, you twist, put them together, try to make use of those pre-trained components. You can also, yeah, wrangling is just. But this is fine because we did not go into retriever. I will have now, given our time, I want to. Do you want to see code of GPT 2.2 and GPT 3.5 now, so that you get to practice? Tomorrow, I will talk about benchmarks. I'll talk about what are the evaluation data sets, and we'll spend good amount of time on what are the data sets available for you. Can I move to the code part and focus at a high level on GPT and BERT? Okay, perfect. Yeah. Unlike yesterday, today I don't have many questions. What is the reason? Any question or view? All right. So it's like 10,000 feet or 100,000 feet we can look at. Sure, ma'am. I think then if the crux of the NLP is from the symbolic representation using synonym like WordNet to static vectors where every word is converted into a numerical vector form, multi-dimensional vector form, was a good progression from 1980s to 2000. From 2012 to 2022, the next progression came. These static vector representation, right? They became a deep contextual distributed representation where it was able to have the context well brought into those multi-dimensional vector. So in the process, the vector also size increased. Earlier, it was 100 to 400 dimensional vector in static. Now it is starting at 512, 768, 1024, and so on. So the number of dimensions of the vector is going. So these are the three broad things that we can keep in mind. All right. So GPT is, like I said, it is an auto-regressive model. So the loss function here, we will break this into, it's an auto-regressive loss function where every word that it predicts on the top of the decoder, right, that goes as an input into the decoder. The way perhaps we can decipher this, the loss function is, if you look at the numerator, you have xt, the current vector that is being discussed. And this xt is the sort of a dot product of it with the previous state, the hidden state of the vector over there of previous timestamp. So t minus 1, so that previous timestamp vector, it has been dot product with, and it is exponentiated here. And with log, anyways, you can inverse it and you will have the base value coming. And it's divided by the values of over time. Those values are put together and summarized. At a high level, this is, so the objective is how do we reduce, how do we maximize the accuracy or reduce this loss that we are having. Now, all right, model parameters or numbers are there. We will look at the way we looked at the transformer, right? We will see at the bottom, you will see the rock rules, and we have a start of the sentence and end of the sentence. Here we presented. Even start of the sentence and end of the sentence are important. And in case of BERT, it is CLS and separator. The start of the sentence is called CLS token and SCP token at the end. So these are very critical to know when your sequence ended. All right, let's go look at the first one. At a timestamp 1, T1, this data is tokenized and some sort of a static embedding. A vector is this x0, and it goes through some hidden state. So there is no value. So you will have some initializer here, and the expectation from here is you will get the next word that it is expected to come is D. So now what we have to, I will move to the next timestamp because here a rock example is available. But then let's look at the next timestamp T2. The embedding is x47, and the hidden state, another vector is here, which is also having some sort of, it is more like the RNN, where you have, it concatenates the previous timestamp concatenates to this hidden state. And the data that you get rock comes from the hidden state and a sort of the previous value, let's say the x47. So D will come from x47, and D will have a x47 and hidden state to predict rock. Now, similarly, rock is embedding and hidden state, and you get. Now, let's move to the next level where rock is an exponential of the product of x30 and h2. So that product is what should give you the rock. Now, this is if you look at transformer blocks, if I have to put it, what happens inside is you have those hidden states and moving. And in this case, the movement is only one direction. So it can only it can only compute the previous data. It will not look at the forward data. In any case, there will be multiple transformer blocks, and the output should give you some sort of a probability distribution where you expect the will have high probability distribution in the first column, let's say. And that we didn't show here. Ideally, the data, the D comes as an input. Along with this input again goes and rock comes and so on. Now, attention heads, unlike in the transformer architecture, you have both. They said you can have any side. In case of GPT, the attention is only to the preceding items. For example, you have word 2, rock will have a dot product with D, and rules will have a dot product with D and rock, both of them. So this dot product you see in both the cases. But then if you notice, D doesn't have any dot product. So it's only the preceding items it looks at. All right, so this is nothing but, so in this case, there's also teacher forcing, I'll share. So let's say you're doing one hot encoding of value. So you have 1 and all zeros, and the beginning of the sentence, BOS, and expectation is you predict the. But then what it has predicted is 1792348 and highest is this 9. I do not know where the 9 is. So let's say this D is not 9. The 9 is, let's say, rules. While it wrongly predicts here, in the teacher forcing method of GPT, the next timestamp it receives the actual the vector and not the wrong prediction vector. If you do not understand, in any case, we don't fine tune GPT, we can skip. But essentially, that is what I wanted to highlight here. And then you will also notice the dot product lines you have only with the preceding ones, not of the future state. Okay, generation, now you see the data when we are generating, the previous data comes as an input to the next one. But in GPT, it is always the last word, which is getting the data from rest of them and is using. So it is always going, the output goes as an input to the next one, which is what we call it as auto regression method. It's a regressive model. Or the fine tuning will not go into details while you can run this method. Oh. What happened? All right. Now, all right. So GPT size kept on increasing, and so when I come to size, I only focused on parameters till now, right? We had the first GPT in 2018 at 117 million parameters, and GPT-2, which we will see, it had 1.5 billion parameters. Now, GPT-3 has 175 billion parameters. Now, the other ones, layers are encoder blocks in the transformer. The base one had 12 layers. It was equivalent to BERT base. And GPT-2 had, and of course, these are decoder layers. And GPT-2 has 48 layers, one above the other. They are stacked, and GPT-3 is too crazy, way too many layers. Now, the number of dimensions in GPT-1, sort of, they never named it as one, are 768 dimensional vector. The vector length was 768. Now, 3 has very, 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 very big, 12,288 dimensions. And we don't even know that, I wouldn't know, feed forward, how many are there? There are some rumors, of course. Okay. Now, let's look at, there are models where these are scaled up. You have here with GPT Neo, GPT-J, which you could work on if you want, but the scaled down models are also there. But let's, I'll focus only 2-3 key aspects of BERT so that we can run the code. Now, unlike in GPT, in BERT, you have CLS and separator as start and end. Now, it is similar. You have a token for every embedding for everything, x47, x30, x34, x1, and all. These are embeddings. And positional embeddings are PO, P1, P2, P3, P4. But then what you have not seen is sentence A. Yeah, sent A is here. Because BERT is trained on premise, on hypothesis separately. So what is the premise and what is the hypothesis? These are trained differently. So I think sent A is a premise and sent B will be hypothesis. So question and answer, a sort of question and answers are, they both have a separate embedding added to classify which one it is. So they found the accuracy is likely to be better in this case. But then it also has 12 to 24 blocks. Second aspect which is important is in this case, these are masked models where in a sentence 15% of the data is masked. So, and then the model runs sure, I'll talk about 9. So what I was saying, yeah. So in the masked model, so there is a big sentence that you pass, right? In that, let's say you have 30 words. So 15% of 30, you will, so which is 4.5, let's say round it of 5 words. 5 out of 30 words are masked, and you run the model to predict those masked values. What is that word? So that is one that happens. Second, they also, what they have done, they gave a wrong word instead of, let's say, masked language modeling is the technique used in BERT. So here, after masked language, they said beauty is a technique used. So beauty is an impure word, and expectation is that the model rectifies and gives the answer. I think these 3 are the foundation blocks for it, and it runs on an encoder side. Okay. Now, loss function is similar, but I think will not go into details. I have this question saying, in the previous diagram, the was not highest probability, and yet highest probability was 9 something else, but the was chosen. So it is a vector. It's a token number. However, let's say it is not same. So general expectation is whatever is the output that you get right from each vertical, that goes as an input to the next layer. So in a teacher forcing method, even though it gives inaccurately, the correct one only goes to the next one. So you force fit so that those layers will get it right first, and afterwards you go into within the layer how to correct it, or within the vertical how to correct. So it's teacher forcing method, and you use it in fine tuning. So very, very, very rare case example. All right. Any questions on these two models? Otherwise, I will go to the code. So let me give a pause. So far that we discussed, any questions? So I'm going to run, I'll give you a requirements file. How do I generate a freeze? Mister, how do I generate a requirements file?
Pip freeze.
Pip freeze, yeah. Oh, greater than, oh yeah. Greater than requirements. .txt. So I'll basically whatever libraries I have, I generated, I will have this sent to you all so that you could run. This is one. Yeah, so we will share this requirements document. And now we'll talk about GPT-2 as a starting point. GPT-2 is an open source model, one. And your transformers, from transformers, courtesy Hugging Face, you can install transformers. They have all these open source models available. From transformers, I'm importing GPT-2 LM language model head model and GPT-2 tokenizer. Tokenizer will break a sentence into series of tokens. It is very similar to what we did yesterday, where I did a lot of data pre-processing, right? Lemmatization and so on and so forth, stop words removal. Here we don't remove any words, but then you do cleaning of the words and have all the words together. So it can be contracted or not, and so on. All right, so I'll run it for you so that you see it is working or not. Then model name within this, I'm taking GPT-2. So, and I can use the model name both for the tokenizer and language model. So tokenizer, I passed it saying within this library from pre-trained, take GPT-2. Yeah, I will run it for you. So though it will take 2 minutes or so. And then I created a, maybe it's too small. It didn't run. Okay, it is already there. Now, then I'm defining a function where within this I pass two variables. I'm expecting to have two variables, question and context. Now, tokenize question and context, input text. So giving context and question. And then input IDs I have provided here, input text, whatever text comes here, that gets encoded here. So that's how input IDs I'll get. So special tokens are kept as true. So you will have all of the data without missing will appear. In the output, I will generate from this model, GPT-2. I'll generate, use the input IDs. And this is what you have as part of the library itself. And the parameters that we need to pass. Max length is essential parameter, max length. Oh, anyone has to be there. Max new tokens or max length will define how many tokens as an output it should give. And return sequence is equal to 1, it will provide an answer. Generated text is you decode the text and provide the actual text from from the whatever encoded one to this. Now I'll run this function. There are multiple questions here, but let me run one question. So here what I did, question 3, what is the chemical symbol for gold? And gold is a chemical element with the symbol AU and atomic number 79. This is the context provided. An answer we are expecting in the answer in the function, we said we are passing question 3 and context 3, and we are trying to print that. Let's see what it will print. Now, we gave a context of gold is chemical element in the symbol and atomic number 79, and we asked what is the chemical symbol, and see what answer it gave. Answer 3 with context, this text is gold is a chemical element with symbol blah blah blah. And then it also gave another question, what is chemical symbol for gold, and then what is chemical symbol for silver, and so on. Let me increase the max length here to 150, and then see what all it will answer for me. So because the length we defined, so what is the chemical symbol for silver? It's the chemical symbol for silver is silver. It has no clue what it is doing. Let's ask a tougher question. So I will ask from the one of the earlier question that we said. Okay, so we will take this. So this data I will provide as a context. Okay, so all right. So what I'm doing is I'll say context n, and we'll say question n. We can ask one question, and then let me delete this. Answer n. Insert question n. Let's say. We will retain the same question and see what it is going to answer here. It is printed. What is the chemical? Okay. Why did it print answer within the count? It has printed all of, okay. Input length IDs is 167, but max length is given only 150. Okay, let me increase that here. Good observation. Now, because our input length is large, so we asked what is the chemical symbol for gold. It did not shy away from responding. It said chemical symbol for gold is G. Is it right? Entire textbook. Now short. We saw the maximum length. It is wrong. It gave a wrong answer. Chemical symbol for gold kept on increasing, so it's wrong. So it has limited capabilities, I would say. Now, how much can it handle? We looked at the sizes, right, of GPT-2. No, we didn't have size here. So the maximum it can handle, the number of tokens it can handle are limited. I think it is 1024. It's 1024. Yeah, it's 1024. If you have more than 1024, it will not respond at all. Yeah? It will not be able to handle. You give a book, it can't respond and it will just truncate after that. It will truncate after that. So you run this code, and I will show you now GPT-3, which is what I want you all to experiment also, GPT 3.5. In this, there is no code. I've got a lot of stuff explained, but let me just create a new file. That is better. So very simple steps I will take. To be on safe side, I'm taking OS, but otherwise it is also not required. Import OpenAI, and this is a library that we have. After that, I have certain parameters are available, and we will define those parameters. I'll explain each of those parameters, but first I'll share those parameters. I'll update all the parameters here. Then okay, this is my personal key, and there will be bill on me, but that's okay. It will not, you may not use it that extensively. I'll keep it available for you all till tomorrow. Let me take the rest of the code from here. I have two functions, one to get a query answer, another is to construct a prompt in addition to the actual prompt. You all know what is a prompt. So we can play around with prompt a bit now, and we will see what all it can do. Yep. Good. All right. So what I did here, I have imported the library OpenAI, and their OpenAI API key is here. And I will also keep this separately so that you have it very clearly. All right. Okay. Now I'm using this OpenAI key. I am now able to connect to their server. So there are a set of parameters in this get query answer function. And in the beginning, you see there is a conversation and temperature. Temperature by default is assigned to temperature. And that's why we are highlighting. If you want the code to be less, you can even remove this and mention the temperature as 0. Max tokens kept 200. We will keep changing these two to see what is the difference that we can get. Now, what did we pass within this function? Temperature and max tokens assigned. Multiple times we assign and not required. And it is returning OpenAI chart completion. And this function is predefined by the OpenAI team. So we are creating model, we are passing it as GPT 3.5 Turbo. It is able to understand the model when you have an API key. And then max token and temperature we're providing here. And top P is I explained you beam search and greedy search, right? In the beam search, it will provide multiple options of different probabilities of next word that it is predicting. So if you keep 1, it can be it will allow so many options. You keep 0 or 0.1, it will be very, very tight. So I'll keep it as 0.1, very, very tight. Only the very high probability for occurrence, only those words will appear. Message is nothing but the conversation here, but I'll explain more details. And what it is returning is the choices, and the first choice only we are asking message and content. Okay. How to get API key? You have to log into, you register in OpenAI. So you have to register in openai.com. You log in here, and so I already logged in. So API is one of the options, and in the API key, you go to once you log in, you have this option of view API keys. Yeah. And initially, I think for $20 worth, you can run and it will stay for so long. I saw my billing and didn't realize I paid some $40 odd. I only used $9 here. So then October 1st is all of it is lapsed. All right. Now let me go. I'll also talk about it. And then other one is I'm constructing a prompt here. I can pass any arguments where a null conversation is null list is there, and new prompt will have whatever we are replacing this some sort of a reference in the prompt. We added some unique symbol under context. Basically, we will replace this unique value with the context that we provide here. Now, conversation append role. Role is a system and content is a new prompt, whatever prompt that comes. And then we also provided role is the user role and content is the question. User will ask this question and you return the conversation. These two go as an input to this model and we should get an answer. So question is given here. Who are you? Context is here. And in the conversation, question and context is passed. Let's run this. Till where did we run? Yeah. And the parameters chosen are this. And now a prompt I wrote as a compassionate and attentive digital, as a compassionate and attentive data science faculty, give answer only from below context. Say AI and data science faculty. Let's say data science faculty. Okay, give answer from it. Done. Now we will run these functions. I'll share this code with you today. Who are you? We asked a question. Says, I am an AI designed to provide in the field of AI and data science. Okay. Now we will pass some context here. The context that we gave exactly to the previous, in the previous case. We'll run this. The context here provided is about the attention, multi-headed attention. So we'll add this here. Okay. So what is the core mathematics behind? Okay. The question we will ask is, what can you do? And then see how it answers. I can provide explanation, insights, and answers questions related to the core mathematical idea behind transform. Do you see the answer much superior? Now I'll ask a question of whatever is exactly here, which is what is the chemical symbol for gold? Now, and let's see what it is. I'm sorry, but I don't have access to information about chemical symbols. My knowledge is limited to AI and data science. Now so it says this is what it can do. It can't answer anything outside the context. We say you are expert. You are expert in diverse fields and has ability to answer any question user poses to you. Okay. Now this is the prompt that we gave, and then now I'll go. I don't need to have. We'll delete now and see what happens. Okay. Did I run this? Yeah. The chemical symbol for gold is AU. Let's keep some context. So you see that distinction, right? It has that body of knowledge with it. And I add it and see what it is answering. The chemical, still it answered, because irrespective, you can say what is the chemical symbol for silver. It doesn't have data in the context. Context is completely different. Something else we kept. What happened? Okay. Something else we kept. Silver we will ask, and then we'll see silver. For silver is AG. Are you able to see the distinction where it is able to answer correctly? Okay, now, good. Now what I will do, yeah, thanks ma'am. Now, you will have these two files and the requirements document, and what I expect you to do is you prepare summarization. You should be able to give a document and get summary well drafted for you. Now I'll show some details that you need to explore in OpenAI, where you go to the OpenAI and there look for documentation. In the documentation, you have on the left hand side what are different things that are covered. I think spend some time on the introduction itself. You have large language model, GPT. Embeddings are the vectors. So vector formation is through ADA. Now I think ADA 002 is what it runs, embeddings. Tokens, I spoke about tokenization. In every word gets tokenized before it goes through the embeddings. Those vectors is what I work with language models. You have some details of each of these and fine tuning. Now we'll go to GPT on the left side. So here it gives you different model families. So these GPT-4 and 3.5 turbo you can use. Now the person asked, can I keep the entire book? I think GPT-4 has 32,000 tokens limit. The limit is increased, and GPT 3.5 has normal 8,000 and 4,000 and 16,000. Yeah, 4,000 and 16,000 tokens limit is available for 3.5 turbo. All right, updated earlier we had Babbage and DaVinci till last year. I think March they were deprecated. Legacy models between November to June, July, Text DaVinci 003 and 2 are there, which they said January they will deprecate this, or this already Text DaVinci no longer in 2023. Interesting. So here you will see chat completion, where how you could write. You could explore by running the same code. Only thing that you have to do is the API key that I provide, use that till tomorrow evening you will get. Right now, I'm going to paste that API key in this group. Will you be able to take if I give in this group, or do you want me to share with the organizers data? Oh. Okay, so what you should get, one API key, two these two files I'll provide, and three you will also have PPT. We'll make sure you have this time early all these details for you to look at. So go into the details of chat completion and how can you write a function and call the function. What we did is we wrote a function and we kept calling, and then completion API we used something like this. Prompt we defined earlier and we called. Managing tokens, that is fine, you don't need. Then embeddings, these are also is okay. So emphasize till here the details. You can then run with it. If you don't want to write code, or you don't have time till tomorrow or day after you want to do, go to Playground. In Playground, you are a help. You say you are an expert computer science engineer, computer science faculty, and say now you're saying what is quantum computing, explain mathematical reasoning. Okay, submit. And then here you see the model that we are running is GPT 3.5. You can choose super good GPT-4. Temperature is 1. Now I said I'll explain temperature. It is the how creative or how specific. Low temperature would indicate it has to be very specific to what you provide. High temperature would indicate it can be creative. It can make some it can provide diverse length. Max length, we already saw what happens. Stop sequence if you want to stop. Top P is the probability, what probability limit you are keeping. I generally keep 0.1 because I focus more on accuracy. Frequency penalty and presence penalty are you can look at. I'll run this and check what happens. Sorry. Is a type of quantum bits machine. So we chose GPT-4. It is very verbose, GPT-4 here. Entanglement, superposition. Yeah, you have excellent. It says to encode information zeros and ones and in different states, you can get that. Fundamental principle is based on quantum mechanics. There is like superposition and entanglement to perform operations. So what is superposition you have here? And qubit. Superposition is qubit. Entanglement. All right. So you can change that. You have to we'll say you need to explain every question understandable to a sixth grade. My son is in sixth grade, though he doesn't study at all. But yeah, sixth grade student. And the same question we offer, and we'll submit this. And see this time what answer you will find. Look at the answer. So based on this, it started giving, if you have 10 apples and you eat 2, blah, blah, blah. So math is the process of, so it has completely ignored the quantum computing. It just gave mathematical reasoning as an explanation. So you can play around here also if you wish. All right. Tomorrow there is a 4-hour session, ma'am. So I am worried of how to deliver 4 hours. But let me see, I'll work from home tomorrow. What is the URL you are showing for which? Oh, this one. It is in the OpenAI. You can take, I'll paste here. You basically go to openai.com and explore. I think you need to register over there. Oh, why the messages are going to only one person and not to the whole group? How do I
select everyone?
Very,
on the first one on the top. Everyone.
Oh, everyone in the meeting. All right. Now I will also give this. Okay.
They need access.
Huh?
Access.
They need to have. This playground is free. If you want to use API key, right, that we have. And we have Azure OpenAI APIs. So when we show it to third person here, right, I'll share this code, but you will not be able to run. I'll share both the GPT 3.5, what we tested. Here I have an Azure OpenAI API key. This is, anyways, is all in the .env file, which is not accessible. There are company our API keys. These are not exposed at all outside. But I provided a lot of explanation for the function which I just explained to you. That explanation is provided here. You could use this as a reference. And the bottom one is only from the external OpenAI endpoint. All right. So today, what we have looked at are one. We said very briefly, we again revisited the transformer architecture. 2, we said how the growth is going towards zero-shot learning. Then we said the number of parameters or the weights as an output from the models are going to 1 trillion and more. And then suddenly there are also these small size models with retrieval augmentation have come. Increasingly, the control is possible through using your own data as a reference and not going into artificial general intelligence. Then we spoke about briefly on the autoregressive model, the intuition we looked at, as well as BERT, the masked language model, which is from Google itself. That one. Then we ran a piece of code using GPT-2. This is an open source version. And we downloaded the library and asked question. We realized that its capabilities are very limited. Then we used the external API and ran the GPT 3.5, and we found its capabilities are immensely high. And it was also reinforcing that increasingly we are going towards more general models. So foundation model where you can use the same thing for multiple domains, that direction that we are going. Any questions, thoughts of today? Maybe if one or two people, if you can express in words, I'll be very happy to understand what is your experience. What did you learn today? And what all have been bouncers? Anyone else to comment? Okay. All right. What is the metric for thanks? Metric for ChatGPT. See, you can, whether it is accurately responding or not, So that is a simple metric. You can do a confusion matrix, run an F1 score, or precision in recall you can run. That is one metric. Basically, you want it to be accurate, right? Whatever is the human annotated response and whether it is same there or not. Perplexity, you can check. You can use a lot of machine translation metrics. Machine translation metrics. Give me an example of a machine translation. Glue. Glue is a data set. Tomorrow I'll explain. There's multiple machine translation metrics which you could use here, whether you are getting exact response or not. Metrics for a GPT. All right. How to find accuracy? It is randomly given. So you can see you have the correct answer, and then you will allow the system to generate, even though in that randomness, that is what we are saying, right? The probabilities are very good. So run it always with your own context. Correct. So you can run an F1 score, but the evaluation is against your data, right? For every question, you should have an answer. You allow the GPT to give an answer and compare F1 score between these two. You need basically precision that it is able to give correctly or not. Tomorrow, I will explain a little more about a full layer where how we introduced validations. So what kind of processing we did to the data that we passed, and there how did we utilize precision. I will explain that. Unmute. Venkatesh, you're back, right? Let me see. Venkatesh. I thought one of it is unmuted, Venkatesh garu.
Sir,
Huh.
I already tried to create some one language model, but not LLM. So to create a language model, collect the news data of Telugu text. We already collected large data of Telugu text. Sir, my voice is audible?
Yes, indeed.
Yes, okay, I collected large amount of Telugu text. That means news, whatever it may be. But nearly, I think, an MB of data is there. I want to create a language model. But how to check? Is there any already we have checked in ChatGPT or Google, whatever it may be? My language model is working that perfectly or not. So how to check? So given some question, I get some answer. But one question has multiple answers. Now, is it optimized? And you can say that is optimized or not?
So you already trained your model?
Yes, sir.
Okay. Okay. Whichever model you trained it on, see, like I said, you have multiple machine translation. Are you doing translation or generating a response for a question?
No, sir. Just only generation, not a translation.
Generation. Right? Okay. Now, for every question, you keep what is right answer. Whatever is the text, length, long or short, you keep right answer, and then you allow the machine to generate an answer. Once machine generates answer, use FAISS, FAISS, Facebook AI similarity. I'll just write here. Use FAISS. Basically, it is inbuilt with the cosine similarity. Cosine similarity. Now, what you should do is the distance between the answer you have with the answer generated by the model. Look at what is the distance, cosine similarity. You can also do Manhattan distance, but FAISS is fantastic.
That's an relevant distance, okay.
Yeah. And if the distance is, let's say, 0.3, so generally you say 0 means they are very closest, there is no negative value. 0 to 1 means very long. If it is less than 0.3, right, you can safely say your model is excellent.
Yes, sir. But I have I have faced some problems, sir. In English letter is that is only 26 letters. Na? You can easily find out what a distance between letters. But where I am using just only regional language, that is a Telugu text. So that's why I'm facing so many problems.
No, I have to check. I never used FAISS in a multiple language method. Okay, you do another thing. You do one more thing. Madam, F1 score is a combination of precision and recall. What you could do is vectorize the data, vectorize the words.
Okay.
No, in any case,
Okay.
even here distance cosine similarity also you are only
Yes, correct.
vectorizing, right? So when
Okay.
you vectorize, how could I say that it is language? Language is insignificant because you are anyways converting into vectors. Vectors will tell you what is the distance across the dimensions. You didn't correct me. Whether it is
Okay.
Telugu or whatever the language, you have to convert into a vector format only. So I'm guessing you are using BERT multi-language.
Yes, sir.
Oh, good. So go with the 5 and 0.3 or less, your model is good.
Okay, sir. I will try it. Okay.
I think we need
Okay,
to
thanks.
check with sample, apply sample. Okay, one more announcement. Venkatesh Garu, yesterday you were the best faculty identified. All along, I did not see you. Were you there since beginning of the class? Okay, all right. Appreciate all of you taking out this time. Good luck. Please try to run tomorrow 9 to 1. I have to prepare, but I think equally it is also tough, going to be tough for you all. Let's catch up. We might take 10 minutes break in between for me. Okay. Thank you. Take care. How do I stop sharing screen? Yeah.